In this video, I'll continue doing examples of substitution as far as integration goes. So my second example will be a trig example. And what I want to integrate is the sine of theta to the 10th power times the cosine of theta d theta. So remember, this notation, where the 10 lies in between the sine and the theta, that means that you're taking the sine of theta and raising it to the 10th power. So that's just a quick little reminder about trig. But anyway, I want to integrate this function. And the first thing I need to do is decide what will u be equal to. And depending on what I select for u, I should also be able to make a substitution for du. So again, we have a product. We also have a chain rule, or I should say a composition of two functions. And so in this composition, the innermost function is the sine of theta. And that is what I'm going to let u equal to. And if I take the derivative of u, or du, I'm going to get the cosine of theta d theta. So now I want to see, can I substitute all of that so that I change out of all theta variables and into this simpler u form? So here I'll have u to the 10th, and then it just so happens, well thought out or well created problem here, it just so happens that du is exactly the remaining piece of this integrand, cosine theta d theta. So what I'm integrating is u to the 10th du. Let's do that integration. Oops. Sorry, try that again. The power rule says that I need to add 1 to the power and divide. Don't forget to add your constant c. So that is the antiderivative with respect to u. Now let's resubstitute my thetas. So remember, u is equal to the sine of theta. And so I want the sine of theta to the 11th power over 11 plus c. Once again, I would recommend checking this. So the check would be to take our answer and to find its derivative. And we want to see if that gives us the original function that we integrated. So if you want to pause and try taking the derivative, hopefully you'll get this expression. All right, my last example is going to be a definite integral. And so I mentioned a little bit ago that the work was a little bit different when you were talking about a definite integral, because what you can do is you can change the limits of integration so that you don't have to resubstitute. So what I want to integrate is the natural log of x over x with respect to x. And I want to go from 1 to e squared as my limits of integration. So first of all, let's pick a u, and let's be thoughtful about du as well. So we really have a couple of options here. We could let u just equal x. We could let u equal the natural log of x, or we could let u equal 1 over x. So I might rewrite this just to remind you that when you have the natural log of x divided by x, it's really the same as 1 over x times the natural log of x. So those are equivalent forms. And It turns out that letting u equal the natural log of x is the best bet here. And the reason is that when you find du, the derivative of the natural log of x is 1 over x. And so that actually gives us this other piece right here exactly. And the ability to spot that comes with a little bit of guessing and checking at first, and then a little bit of experience and wisdom, and you'll be selecting those values easily. In the homework, actually, they're gonna tell you in the beginning what to let u equal, and you'll see a couple of examples, and then they'll leave you on your own to decide. Let's do the substitution. For now, I'm going to leave my limits of integration blank, but the natural log of x is what I let u equal, and then 1 over x dx is my du. So let's talk about that change of variables. Okay, so before I was integrating in terms of x, and so these values are given in terms of x. Now I'm going to integrate in terms of u. So if I want to use the fundamental theorem of calculus, I'm going to have to change these lower and upper limits. So remember that this is the equation that relates u to x. So if I have 1 as my lower limit of integration in the beginning, then I need to do the natural log of 1 in order to get my lower limit of integration here. Remember, the natural log of 1 is 0. Okay, if my upper limit of integration was e squared, then I need to do the natural log of e squared in order to get this new upper limit. And remembering the properties of natural logs and e's, that just gives me 2. So now I'll integrate this with respect to u du, u squared over 2 using the power rule. I don't need to add c because it's a definite integral, but now I need to evaluate it from 0 to 2. Now let me just quickly tell you, let's say you did not change your limits of integration. It would technically be incorrect. However, if you go ahead and you resubstitute the natural log of x back in, and then integrate from 1 to e squared, you will get the correct answer in the end. So the thing you have to remember is, do your limits of integration match the variable that you're using? And again, I can use the fundamental theorem of calculus in order to find this. So I've got my antiderivative. I just need to plug 2 in, and then I need to plug 0 in, and I need to subtract them. So 2 squared will be 4, divided by 2 is 2, minus 0, and so I get an answer of 2.